Figure 1.1 shows the results of an experiment to find how the current in one of the lamps varies with the potential difference across it. We can see that the potential difference ranges from 0 to 6, and as it increases, the current also increases to the maximum value of 250 milliamps when the PD is at the maximum. We need to draw a diagram of the circuit that we would use to perform this experiment, which shows how the current varies with potential difference across one of the lamps. For this experiment, what we need is a potential divider circuit, because we want to get a range of potential differences across the bulb. And we will use a 6-volt battery, because that's what the maximum potential difference we want to get, connected to a variable resistor, and we will connect the lamp there with a sliding contact across the resistor. What this does is essentially split the resistor into two parts, so that we have got two separate resistors with different resistances, and they are connected in series, which means that the EMF of 6 volts will be shared between these two resistors, with the sharing will be proportional to the resistances. So at this moment this part is longer, that has a higher resistance, so this will get more PD out of this battery, and this will get less, but as we move this contact, if we put it halfway, then the split would be 3 volts and 3 volts. So by moving the contact across all the way there, we can, in this situation, that would give us 6 volts, because all of the voltage is going to be taken by that part. And then if we move the contact across there, then 6 volts will be on this side, and then on the other side there will be nothing left, because it does not have any resistance. So that's how the voltage can be split. But what is important is that we want that voltage across the filament lamp, and that's why this connection of the lamp is in parallel with that part of the variable resistor. Since they're in parallel, whatever voltage is in this section, so we can call that V lamp, it will be the same across the lamp, because they're in parallel, and the voltages that we get as we move the slider across will be able to get the same voltages across the lamp. That gives us the desired range of voltages, but we need to measure the current and also this voltage. To measure the voltage, we need to put a voltmeter across the lamp, and to measure the current across the lamp, we need to put an ammeter. And remembering that the ammeter needs to be in series with the lamp, and the voltmeter needs to be in parallel.